Okay, today we're going to talk about molar ratio. So this is part 2 of section 1. So the molar ratio is a ratio between the numbers of moles of any two substances found in the balanced chemical equation. So when you're starting to do this, you need to make sure that you have a balanced chemical equation. So let's start off with writing a balanced chemical equation for the following problem. So we have nitrogen oxide. It's present in urban pollution, is immediately converted into nitrogen dioxide when in the presence of oxygen. So here's the important stuff right here. Nitrogen dioxide, nitrogen oxide, and oxygen. So let's write this balanced chemical equation. So NO reacts with oxygen O2 to produce NO2. Not balanced yet. So it's 2 and 2. So now we're balanced. So we have to write this in terms of moles. So yesterday we kind of went over and we wrote it, we interpreted our equation. So let's look at this. So we have 2 moles of nitrogen oxide, 1 mole of oxygen gas, and 2 moles of nitrogen dioxide. Okay, so that's what we have. So now we're going to write out the molar ratio. So this is just a small step that we're going to use in the next section to be able to convert from one substance to another substance. And so all you have to do here is, so we are going to start with, say we're given moles of or grams of nitrogen dioxide, we need to figure out how much oxygen we have. So let's start with how many moles from the balanced equation that we have of nitrogen dioxide, and that would go on the bottom. Look at the balanced chemical equation. We have 1 mole of O2. So that's our ratio. Well, we can do the same thing. Say we have the product, nitrogen dioxide, and we want to go to the other reactant. So we have 2 moles of NO. And so basically all these ratios are showing what you have. Say we have our reactants, we have the mass of our reactant, say oxygen. So we have 1 mole of oxygen. We need to find the mass of the other reactant. Well, that would go on top. So when we're writing these, they seem kind of tedious because they're going to be a little redundant. Excuse me. Because you're going to write it for every single option that you have because you don't know what you're going to be going to. So always on the bottom, you want to put what you are given. And on top, you're going to put what you need to find. So they're all possible ratios. So overall, when you have an equation like this, or a balanced chemical equation like this, you should have 6 molar ratios. So this isn't really that hard. It's fairly easy. Some of your problems are only going to ask you to put like 2 or 3. So let's do another one. The hardest part is making sure you have a balanced chemical equation. So let's see what we have. We have hydrogen peroxide here. Decomposes to form water and oxygen. Okay. So hydrogen peroxide is H2O2. Decomposes, so we know it goes like this. H2O plus oxygen gas. Okay, so we got to make this even, and we're balanced. So we have 2 moles. You don't have to do this step that I'm doing right now. I'm just showing you how many moles we have. 2 moles of hydrogen peroxide, 2 moles of water, and 1 mole of O2. Okay, so let's write the molar ratios for these. So if we are given 2 moles of hydrogen peroxide, we need to convert it to water. So you put 2 moles of water on top. If we're given hydrogen peroxide, we want to put what we would need to go to. So that's 1 mole of O2, the other product on top. Say we're given how much mass of water. We could collect that. We know how much water we have, so we put water on the bottom. We need to find out the other product, so we would put 1 mole of oxygen on top. So let's see, we start with water again. Mole H2O, and we need to figure out how much reaction we started with. So then you would put 2 moles of H2O2 on top. And our last one is going to be our oxygen. If we start with our 1 mole of O2, we need to go to hydrogen peroxide, 2 moles of H2O2 on top. And if we need to figure out from oxygen how much water we have, we would put 2 moles of H2O here. So basically, you're going to determine how many molar ratios you have, or all the possible molar ratios for the thing. Now, this isn't a really hard concept, and so you do have a little, it is time consuming. I do understand that. That's why you're kind of limited on your problems for this. Okay, this is a big step. You need to know how to write these molar ratios to go on to the next step. So again, we're taking baby steps to do a bigger problem. All right, you guys have a good day.